Hi, my name is Eric Abele. Today I'm going to be presenting on a collection device for dolphin hormone sampling and blowhole jet flow fields. This work has been done through Oklahoma State University in partnership with Unmanned Systems Research Institute. So as far as the motivation goes for this project, biologists need a way to measure cortisol levels of wild dolphins to determine their stress levels. Cortisol can be sampled from mucus and dolphin blowhole breaths, which can be seen on the video on the right, where a lot of the finer particles emitted are a mixture of mucus and seawater. Mucus is already being sampled from whales today using drones. However, dolphin breath jets are much lower and much quicker. So this research will attempt to understand the flow interactions between dolphin breath jets and a collection device. Additionally, drone-based collection will offer a less invasive method for obtaining samples in the future. So for previous work done, a chuff simulator has been created using pneumatic air cylinders and interchangeable nozzles to replicate the dolphin breath jets expelled. Additionally, in vivo observations were conducted using backdrops and high-speed cameras on live dolphins. This was used to be able to collect actual live dolphin breath jet characteristics. Additionally, high-fidelity scans of dolphin respiratory systems were done to create a CFD replication of the jet emitted from the blowhole itself. So for the design approach, a UAV will be equipped with wing-mounted petri dishes for the cortisol collection. The design challenges that will need to be addressed are the dolphin's field of view, so where the UAV will need to approach for the actual sample collection. The UAV noise, certain frequencies can scare the dolphins, causing them to disappear and go under. And then the breath jet collection window itself, it happens very quick in a matter of 0.29 to 0.31 seconds, as well as making sure that the servo-operated collection device will be able to operate during in-flight conditions. So for the experimental approach, 3 primary areas were evaluated. This included flow visualization, PIV, and flight test. So for the flow visualization setup, setup was conducted in an open wind tunnel at 6 meters per second. Fog was used for the seeding. Double pulse laser combined with the Motion Pro camera were used to capture the flow visualization images. The software that was used to pair the laser pulses and the camera firing was Motion Studio. So for the flow visualization results, we can see on the image on the left that the flow enters inside the dish and then begins to settle down there and collect in the bottom, where that begins to then seep out on the sides. The image on the right shows the flow separation behind the dish itself. So for the PIV setup, it was conducted in a water tunnel using a static petri dish. All of the results were analyzed using the software Diviz. Reynolds number calculations were done to correlate the water speed to the dolphin speed itself. So 0.2 meters per second in the water tunnel will represent the minimum cruise speed of a dolphin. 0.3 represents the high end of their cruise speed, and then 0.5 meters per second represents their max speed overall. So for the PIV results, the 0.2 meter per second test and the video can be shown on the left. It shows that the particles begin to rapidly decelerate once they reach that inside area of the dish and then begin to settle at the bottom. The picture on the right confirms what is going on, where the blue area is the flow entering in, and then the black area shows the flow essentially stopping at that point and being zero there. So for the 0.5 meter per second case, it can be seen the particles are moving much quicker this time. However, as seen before, the particles begin to rapidly decelerate once they reach that inside area of the dish. The picture on the right confirms what is going on, with the 0.5 meter per second flow going in and then hitting that dead area, the black spacing, and showing that the flow essentially stops there and collects inside the dish. So for the experimental flight setup, A Foxtech Nimbus VTOL UAV was used with the collection devices mounted to the wings. These collection devices are servo powered devices used to operate the dish. The main point of doing this is to have the dishes being closed when taking off and then flying out to the area where sampling is going to occur. Once there, the dishes will then open and collect the samples and then immediately close and fly back. This is to reduce all of the in-air contamination that would occur during flight from the boat to the dolphins themselves. So for the flight test results, the collection unit was operated in VTOL mode. The vehicle was able to complete an entire flight route, which consisted of taking off, flying a circular pattern, and coming back and landing. The vehicle did show a slight lateral and directional instability. However, the pilot indicated that the collection devices should be moved further inboard for future flights. Next, chuff sim testing was conducted. This testing was to determine the optimal seating to be used for the collection testing. This was using a mixture of glycerin and chalk. Different nozzle configurations were used, first being an open tube blowhole nozzle, and the next being a Dolphin replica blowhole nozzle to get a better replication of a wild dolphin. So as far as the seating results go, the open nozzle produced a tighter group for the simulated chuff. This was found to be in an area of 14 by 16 inches compared to that of the Dolphin replica nozzle, which was in an area of 14 by 29 inches. The seating was able to stick inside the dish itself. So for the overall conclusions, the flow visualization in PIV show collection is possible. The flight test proves that vehicle collection is possible as well. So for the future work, the vehicle will be used with the chuff sim to collect actual samples themselves to determine the overall effectiveness. I would like to thank my advisor, Dr. Jamie Jacob, as well as Dr. Jason Bruck, who has been a huge help in the biology aspects of this project.